Kevin at Keysight. Today I'm going to show you what the DSA feature for Keysight Infiniium real-time scopes offers over the DSO versions. The first thing is that the scopes will typically get double the acquisition memory over the DSO. That's not true for the S series, as the standard memory is quite generous. Other than that, though, they get three packages: EasyJet, EasyJet Plus, EasyJet Complete. It's more or less one package, and the HighSpeed Serial package. First, let's take a look at EasyJet. EasyJet gives you basic jitter analysis tools as shown here. For example, I have PRBS data on acquired on channels 1-3. I can plot the TIE histogram, which shows me the distribution of the jitter, and I can also do a trend of the jitter. This gives me a visual representation of what the jitter looks like versus time, and also a jitter spectrum, which is good for identifying what frequency the jitter is at. It's also worth pointing out that we can also put measurements on the trends or even the jitter spectrum, and the jitter spectrum also has peak callouts. A wizard is provided. For the TIE histogram, we have full statistics available, and it's not just TIE, but other measurements can be analyzed in this fashion. Next up is EasyJet Plus and EasyJet Complete. This is a tool to separate jitter into the subcomponents of different types of jitter. It'll give you the RJ, RMS, and the data-dependent jitter, duty cycle distortion, intersymbol interference, and several views of looking at this data are provided. Composite histograms, bathtubs, total jitter histogram, the RJ-PJ spectrum, data-dependent jitter versus the bit in the pattern. We can also do two methods of jitter separation. One is a spectral method, and the other is the so-called tail fit method. The tail fit method is used to find bounded uncorrelated jitter, the typical source of which is crosstalk. There's a lot of ways to look at these graphs. We can just simply double-click on one, and it'll zoom in on it. Or we can double-click again, and it will zoom out. I can move the graphs around as I see fit. And if I want to see only, say, 4 graphs, I can change that quite easily. Click here. Click 4, and it picks the first 4 graphs. And the bathtub curve as well. We can still zoom in and so forth. This is an excellent tool for understanding the different components of your jitter. EasyJet Complete, which is basically the same kind of separation, except that it's on the 1 level and the 0 level. It's the noise and vertical interference. So if you can break up the noise on a 1 level and or a 0 level at the same time into its types of sources, your random noise, your deterministic noise, and so forth. It's very, very similar. Next up is the HighSpeed Serial package. This is also included with the DSA version, and it essentially gets you the so-called real-time eye plot. One of the nice things about the real-time eye plot is that if you are using it with mass test and you have a mass test failure, it can unfold, so to speak, the eye, and you can go to the failure location or locations. It gives you the number of UI for each waveform. In this case, I only acquired 1 waveform, but I have about 420,000 UIs in a particular waveform. It's worth noting that while I'm doing EasyJet at the same time using constant frequency clock recovery, I can do a second order PLL here. I've cleaned up the jitter significantly compared to the constant frequency method, which shows you all of the jitter. Also included with the HighSpeed Serial package is a generic 8B 10B decoder, which can also be used to search for specific bit patterns in an 8B 10B serial stream. So to summarize, we get the EasyJet tool, EasyJet separation for noise and time domain jitter, and the HighSpeed Serial eye diagram and 8B 10B tool. Thank you for your attention.